This presentation is about completing the square. Completing the square of a quadratic involves transforming the expression ax squared plus bx plus c to a form whereby a will be outside of a bracket and x plus p, that's a new value p, inside of a bracket, close bracket, and the square will be outside now of the close bracket plus a new value called q. So here we have an example, 3x squared plus 12x plus 20. Now we can go through this using steps. The first step is to identify A, B, and C. So here we identify A to be 3, B to be 12, because A is the coefficient of x squared, B is the coefficient of x, and C now, which is the constant, 20, the number by itself. Now, the next step, a very important step, is to factor out A. We will discuss a reason for that. So we factor out A, which is 3. We're going to use square brackets. We're going to see the reason why. So we factor out A, which is 3. Now to get the quotient to be placed into the bracket, the square bracket, we have to divide by 3 because it's 3 we factored out. Okay. So we divide 3 by 3 here. We get 1. There's an invisible 1 there. We divide 12 by 3 to give us 4. Okay. So 3 divided by 3 is 1. 12 divided by 3 will give us 4. And 20 divided by 3, it remains as 20 over 3 because 20 is not a factor of a multiple of 3. And then we close bracket. So we have a new quadratic inside of the square bracket, whereby the new value of A is 1. There it is. That's what we wanted to achieve in the first place. The new value of B is 4, and the new value of C is 20 over 3. So now we need to calculate the value of P now. And the rule says P is equal to B over 2 whenever A is 1. So that is why we need to get an A of 1, so that we can calculate P. Our new B is 4, so P is equal to 4 over 2. 4 over 2 is 2. So now we can continue, we can proceed now to open this curved bracket. That's why we have a square bracket in the first place, because we're going to have a bracket in a bracket. So we're going to use different style bracket when that occurs. So now we have a curved bracket here. X plus P, we got a value of P to be 2, close bracket, and a square outside of the curved bracket. Plus Q, we need to find the value of Q. Q is equal to C minus P squared, that's the rule, always. So whatever you get for P, C minus P squared, that will give you Q. So now we have to use the new C, which is 20 over 3. Okay? Because we use the new B to get P whenever A is 1. So Q now is equal to 20 over 3 minus 2 squared, because P is 2. 2 squared is 4. So we have 20 over 3 minus 4 over 1. 1 was placed on the 4 so that it looks like a fraction minus a fraction. When the fractions have been subtracted using the common denominator, so we have to multiply the numerator by 3 and the denominator by 3. So we have 4 threes, well, negative 4 threes are 12, negative 12 over 3. So you have 20 over 3 minus 12 over 3. Whenever your denominator is common, you can subtract the numerators. 20 minus 12 will give us 8 over 3. Q is equal to 8 over 3. So now we can proceed to write plus Q plus 8 over 3. So you can see this now resembles our completed square. However, we have a square bracket there to deal with. We have to clear it out. We can clear out the square brackets by multiplying by that 3 that was factored out in the first place. So that 3 have to multiply to that bracket there. And the 3 now also have to multiply to 8 over 3 because we are distributing 3 within the bracket. And there are 2 terms. This term, x plus 2 all squared, is 1 term plus 8 over 3. So we have to multiply 3 twice. And you can see 3 appearing outside of the curve bracket. Here it is, which is A in the first place. So the value of A doesn't change. It will always end up at the front of the curve bracket here. And then we have to multiply 3 to 8 over 3. 3 over 1 times 8 over 3. Fraction times fraction. Here, when we did the multiplication of fractions, when you're multiplying fractions, it's numerator by numerator, denominator by denominator. So we have 3 times 8 is 24. 1 times 3 is 3. 24 over 3. 24, 3 is 8. So the value of Q will give us 8. 3 over 1 times 8 over 3 will give us 8. So that is our completed square. We can prove or we can verify our answer using Symbolab. Here we type Symbolab into Google. And if you pause and think of it a little bit, why would they call this program Symbolab? Symbol I get from symbols, and lab from laboratory, the laboratory of symbols, because mathematics translate words to symbols. So I guess that's what a convenient name to call this very useful app, useful calculator. Type Symbolab in Google, and you can go to the Symbolab solver. Click on this, and here you have the Symbolab website, the Symbolab calculator online. It's free, it's available for everyone to use. So we're going to enter the problem. We want to complete the square of a quadratic. And here we have Symbolab helping us. Here we have an example to complete the square of 2x squared plus 6x plus 2, but we want to complete the square of our example, which is 3x squared plus 12x plus 20. 3x squared. To get this square, you type shift and you type 6. That's where the power raised is, the upward arrow, and you put square, your right arrow to move towards the right, plus 12x plus 20. And you can type go, or you can type enter. And let us compare. Voila. Here we can see Symbolab has given us an answer which resembles what we got. So here's our working. We got 3 outside of x plus 2 all squared plus 8. That's what Symbolab got, and it also Symbolab gives us some solution steps. Let's take a look at them. Right. So starting with 3x squared plus 12x plus 20, ax squared plus bx plus c, we end up with a outside of x plus 2 all squared plus 8. A doesn't change. It's only b and c, which converts it to p and q if you want to put it that way. And you can see the answers match. You can always use Symbolab to verify your answers, but here are the steps that we go. That's where we calculate q. And that's where we multiply 3, which is a, by q. To get the new q, we want to put it that way. So you have a q in the bracket. Yeah, just to rethink it, this q there is within the bracket. Okay. But then now we want to remove all of this from the square bracket. Yes, square bracket. So we have to multiply by 8 to get another q, which is 8. So that's the final q. We want to put that way. That's the intermediate q. And look at the final q is 8. And here we have it. As you can see, the steps of Symbolab is a little bit more, there are different ways to arrive at the same solution in mathematics, as we always see. Mathematics is a language. Different people can speak it differently. And the message being communicated is the same. Expressed differently, but arrive at the same solution.